Imagine a celestial event so powerful that it could outshine an entire galaxy for a few weeks. What would it look like from Earth if such an event occurred in our cosmic neighborhood? This is not a scene from a science fiction novel, but a very real possibility in our universe. Today we're delving into the life and potential death of Betelgeuse, a star that could soon light up our skies in a spectacular supernova. A supernova is no ordinary event. This explosive end to a star's life cycle releases an unimaginable amount of energy, outshining entire galaxies and sending shockwaves rippling through the universe. The scale and impact of such an event is hard to comprehend, but one thing's for sure. When it happens, it's a sight to behold. So, what if this cosmic spectacle was to occur right in our cosmic backyard? Strap in, stargazers, as we embark on a journey through the cosmos. Now, let's explore the fascinating journey of a star's life and its ultimate explosive end. A star's life is a cosmic saga, beginning in a nebula and ending in a spectacular explosion, or a quiet fade-out. Picture this journey as an epic tale of transformation, taking place over billions of years in the vast theater of the universe. It all starts in a nebula, a vast cloud of gas and dust. This is a star's cradle where it spends the early days of its life. The nebula's gas and dust particles are drawn together by gravity. As they become denser and hotter, a protostar is formed. This is the first stage of a star's life cycle. The protostar continues to grow, collecting more and more matter from the nebula. As the pressure and temperature increase, nuclear fusion begins. Hydrogen atoms collide and fuse to form helium, releasing a tremendous amount of energy. This is the birth of a star, and it marks the beginning of the main sequence stage. The main sequence stage is the longest phase in a star's life, often lasting several billion years. During this time, the star shines brightly, its light fueled by the continuous process of nuclear fusion. This is the stage our sun is currently in, a typical main sequence star converting hydrogen into helium in its core. But what happens when the star exhausts its hydrogen fuel? The core contracts, and the outer layers expand. The star swells and cools, becoming a red giant. The star now begins to burn helium into heavier elements such as carbon and oxygen. This phase marks the twilight years of a star's life and can last from a few 100,000 to a few million years. The fate of a star after the red giant phase depends on its mass. Stars with a mass similar to our sun will shed their outer layers, leaving behind a white dwarf, a hot, dense core. Over time, the white dwarf cools and fades into a black dwarf, a quiet end to the star's long journey. Stars with a mass greater than about 8 times that of the sun have a more dramatic fate. The helium in their core fuses into heavier elements all the way up to iron. The core collapses under its own gravity, triggering a violent explosion known as a supernova. What remains after the explosion is either a neutron star or, in the case of the most massive stars, a black hole. Each star's life is a unique journey, dictated by its mass and the balance between gravity and the energy produced by nuclear fusion. From their birth in nebulae to their final stages as white dwarfs, neutron stars, or black holes, stars are the key players in the cosmic drama of the universe. Betelgeuse, a red supergiant, is currently in one of the final stages of this life cycle. As we delve deeper into its story, we'll explore what might happen when this giant star exhausts its fuel and meets its inevitable end. Betelgeuse, one of the brightest stars in our night sky, is nearing the end of its own stellar saga. Now let's take a closer look at this celestial wonder. Betelgeuse, pronounced as Betelgeuse, is a red supergiant star. This means it's a star that has exhausted the hydrogen in its core and expanded to a size much larger than our sun. In fact, if Betelgeuse were in place of our sun, it would extend past the orbit of Mars. Located about 640 light-years away, Betelgeuse is part of the Orion constellation, easily recognizable by its 3-star belt. Betelgeuse serves as Orion's left shoulder and outshines every other star in the constellation. Now, what makes Betelgeuse so interesting to astronomers is its status as a red supergiant. Red supergiants are some of the largest and most luminous stars in the universe. They're also quite rare, accounting for only about 1 in a million of all stars. Given its size, Betelgeuse burns its fuel at an enormous rate, meaning its lifespan is much shorter than smaller stars like our sun. It's this rapid burning of fuel that gives Betelgeuse its red hue and supergiant status. But, as with all things, Betelgeuse's time as a red supergiant will come to an end. As it exhausts its fuel, the star will collapse under its own gravity. This will trigger a supernova, an explosion so powerful it will briefly outshine an entire galaxy. The remnants of this explosion will then form a nebula, a cosmic cloud of gas and dust from which new stars and planets may form. This is the life cycle of a star, a cycle that Betelgeuse is rapidly approaching the end of. The question on everyone's minds is, when will Betelgeuse go supernova? Stay tuned as we dive deeper into the mysteries of this fascinating star in the next segment. The Supernova Stage, the grand finale in the life of a massive star, is a spectacle of cosmic proportions. But what exactly happens when a star reaches this explosive end? Well, let's start by saying that a supernova is not your average fireworks display. It's the ultimate expression of a star's power, a cataclysmic explosion that can outshine an entire galaxy. This event is the result of a complex dance of physics and chemistry, a grand performance that has been billions of years in the making. When a star like Betelgeuse exhausts its nuclear fuel, it can no longer produce the heat and pressure needed to counteract the force of gravity. The star's core collapses under its own weight, and in less than a second a neutron star is formed. This implosion sends a shockwave rippling through the outer layers of the star, triggering a chain reaction of nuclear fusion that results in the star's spectacular demise. The energy released during a supernova is almost unfathomable. To put it in perspective, it's like a billion atomic bombs exploding at once. This blast is so powerful that it spews out a cloud of stellar material into space, enriching the cosmos with elements heavier than iron. Elements like gold, platinum, and uranium are all cooked up in the fiery furnace of a supernova. In fact, the precious metals in the jewelry you wear, the iron in your blood, and the calcium in your bones all have their origins in these stellar explosions. But a supernova is more than just a pyrotechnic display. It's a cosmic recycling program. The material ejected by the explosion will eventually become part of new stars, planets, and possibly even life. It's a reminder that we are all made of star stuff. As the great Carl Sagan once said, if Betelgeuse were to go supernova, it would be an event unlike anything witnessed in human history. Predicting the timing of a supernova is not an exact science, but estimates can be made based on our understanding of stellar evolution. Let's delve into the heart of the matter. When will Betelgeuse go supernova? Betelgeuse, as we know, is a red supergiant star in the final stages of its life cycle. But pinning down the exact moment it will explode into a supernova is a cosmic conundrum that has both fascinated and frustrated astronomers for years. Why is it so difficult to predict? Well, it's primarily because the processes taking place within a star are hidden from us, obscured by the star's luminous exterior. So we rely on complex models of stellar evolution, and while these models are incredibly sophisticated, they still have their limitations. They can't account for every variable, every particle interaction, every quantum fluctuation. Current estimates suggest Betelgeuse could go supernova any time within the next 100,000 years. A blink of an eye in cosmic terms, but a timescale that feels almost infinite in human terms. However, these estimates are based on averages and probabilities. In reality, Betelgeuse could explode tomorrow, or it could wait another million years. That's the thrilling and slightly frustrating unpredictability of the universe. So, what signs do astronomers look for? One of the key indicators is a sudden drop in the star's brightness. This could suggest that the star has exhausted its nuclear fuel and is collapsing under its own gravity, a necessary precursor to a supernova. In fact, Betelgeuse has been dimming recently, causing a flurry of excitement in the astronomical community. However, this dimming could also be due to other factors, like dust obscuring the star's light, or a temporary contraction in the star's size. Another sign is the detection of neutrinos, tiny subatomic particles that are released in vast quantities just before a star goes supernova. Unfortunately, neutrinos are notoriously difficult to detect, and it's unlikely we'll catch this signal unless the supernova is imminent. So, where does this leave us? Well, it leaves us waiting, watching, and wondering. We're standing on the precipice of cosmic discovery, waiting for a star over 600 light-years away to reveal its secrets. We're watching for the subtle signs, the shifts in brightness, the whispers of neutrinos. And we're wondering about the beauty and the power of the universe and our small but significant place within it. While we can't say for certain when Betelgeuse will go supernova, we can confidently say that it will be a sight to behold. Betelgeuse's potential supernova is a topic of great interest and speculation in the world of astronomy. As we wrap up our cosmic journey today, let's take a moment to reflect on the celestial marvels we've explored. We first delved into the fascinating life cycle of a star. It all begins with a nebula, a giant cloud of dust and gas. Under the influence of gravity, the nebula collapses onto itself, igniting the birth of a star. This star then lives out its life in the main sequence, burning hydrogen into helium and radiating energy. Once the hydrogen supply is exhausted, the star begins to expand, evolving into a red giant, or in the case of more massive stars, a red supergiant. That's where Betelgeuse comes in. This red supergiant, nestled in the shoulder of the constellation Orion, is one of the most massive and luminous stars in our galaxy. Its size is truly unimaginable, with a diameter around 700 times that of our Sun. If placed at the center of our solar system, Betelgeuse would extend beyond the orbit of Mars, swallowing up Mercury, Venus, Earth, and Mars in its fiery belly. Yet, despite its grandeur, Betelgeuse's days are numbered. As we've learned, red supergiants are in the twilight of their existence. They're on the brink of a supernova, a cataclysmic explosion that marks the end of a star's life. And while Betelgeuse is no exception, the exact timing of its supernova is still a mystery. It could happen tomorrow, or it could happen 100,000 years from now. So, as we bid farewell to the red supergiant Betelgeuse for now, remember that every star has its own unique journey. Each one, from birth to death, plays a crucial role in the grand tapestry of the cosmos. Keep your eyes on the stars, and who knows, you might just witness the spectacular end of a stellar saga.